Hello students, for this lesson, we will have our part 3, the last part of our study of chapter 2, linear programming graphical solution. A minimization model example. As mentioned at the beginning of this chapter, there are two types of linear programming problems. Maximization problems, like the Beaver Creek Pottery Company example, and minimization problems. Minimization problem is formulated the same basic way as a maximization problem, except for a few minor differences. So maya-maya i-explain ko sa inyo kung ano naman yung pinagkaiba ng minimization sa maximization problem. Sa una, parehas lang sila, yung paghanap ng line 1 at saka line 2. Pero i-explain ko sa inyo kung saan sila nagkakaiba, especially dun sa feasible solution area. The following sample problem will demonstrate the formulation of a minimization model. So we have here an example, a representative problem. A farmer is preparing to plant a crop in the spring and needs to fertilize a field. There are two brands of fertilizer to choose from, Supergrow and Crop Quick. Each brand yields a specific amount of nitrogen and phosphate per bag as follows. So kumbaga, we have two products, okay, para sa product mix ratio natin, Supergrow and Crop Quick. Okay, Crop Quick. So meron silang tinatawag na dalawang materials constraint. So yung una, nitrogen, yung pangalawa, phosphate. Okay? So ayan yung kung gagawin natin yung chemical contribution niya, ganyan yung itsura. Okay? So Supergrow 2 pounds ang kailangan niya. 2 pounds of nitrogen at saka 4 pounds of phosphate. Yung Crop Quick naman, 4 pounds of nitrogen, 3 pounds of phosphate. The farmer's field requires at least 16 pounds of nitrogen and at least 24 pounds of phosphate. Supergrow costs $6 per bag and Crop Quick costs $3. The farmer wants to know how many bags of each brand to purchase in order to minimize the total cost of fertilizing. So, dun sa maximization, tinitingnan natin kung sino yung may pinakamataas na profit. Dito naman, sa minimization, kung sino yung may pinakamababang cost o yung gastos. So, minimize tayo ngayon, hindi tayo maximize. So, the steps in the linear programming model formulation process are summarized as follows. Okay, so summary of linear programming model formulation steps. Okay, minimizing cost tayo ngayon ha. Step 1, so ganun pa rin, define the decision variables. How many bags of Supergrow and Crop Quick to buy. Tapos step 2, define the objective function which is minimize cost. And then number 3, define the constraints, which is the field requirements for nitrogen and phosphate. So number 1, gagawin natin yung decision variables. Okay? This problem contains two decision variables representing the number of bags of each brand of fertilizer to purchase. Okay? So x sub 1 is equal to bags of Supergrow. X sub 2 is equal to bags of Crop Quick. So next, gagawin natin yung objective function. Medyo madali lang gawin yung objective function niya, no? The farmer's objective is to minimize the total cost of fertilizing. Total cost is the sum of the individual costs of each type of fertilizer purchased. The objective function that represents total cost is expressed as, so minimize z is equal to 6x sub 1 plus 3x sub 2. Okay, dito ang tinitingnan naman natin yung pinakamababang cost. Kasi nga, minimization tayo eh. So, 6x1 is equal to cost of bags of Super Grow. 3x sub 2 is equal to cost of bags of Crop Quick. Next, yung model constraints. The requirements for nitrogen and phosphate represent the constraints of the model. Each bag of fertilizer contributes a number of pounds of nitrogen and phosphate to the field. The constraint for nitrogen is, so 2x sub 1 plus 4x sub 2 is greater than, okay? Titingnan nyo na, greater than, hindi siya lesser than. Is greater than 16 pounds. Okay? Where 2x sub 1 is equal to the nitrogen contribution per bag of Super Grow, 4x sub 2 is equal to the nitrogen contribution per bag of Crop Quick. So, imbis na less than or equal to inequality ang ginagamit natin, kagaya nung example natin sa Beaver Creek, this constraint requires a greater than or equal to inequality. Bakit? This is because the nitrogen content for the field is a minimum requirement. Ibig sabihin, yung 16 pounds doon, minimum yun. Ibig sabihin, hindi bababa sa 16 pounds yung kailangan nating gamitin na nitrogen. Okay, so hindi kagaya nung sa maximization na kumbaga dapat lesser than, dapat lesser than. Ito naman dapat higit pa sa 16, so minimum na 16 pounds ang ibig sabihin nito. At least 16 pounds of nitrogen be deposited on the farmer's field. If a minimum cost solution results in more than 16 pounds of nitrogen on the field, that is acceptable. Okay? However, the amount cannot be less than 16 pounds. So, hindi siya pwedeng bumaba ng 16 pounds. Dapat higit pa sa 16 pounds ang kanilang magagamit. Okay, siyempre, kawawa nga naman yung lupa pagka less than 16 pounds lang ang gagamitin. Hindi masyadong magiging mataba yung lupa. The constraint for phosphate is constructed like the constraint for nitrogen. So 4x sub 1 plus 3x sub 2 is lesser than or equal to 24 pounds. So malinaw sa inyo yun na pagdating sa minimization, less than or equal to or greater than or equal to ang ginagamit. Sa maximization, lesser than or equal to. With this example, we have shown two of the three types of linear programming model constraints: lesser than or equal to and greater than or equal to. The third type is an exact equality, equal to. This type specifies that a constraint requirement must be exact. For example, if the farmer had said that the phosphate requirement for the field was exactly 24 pounds, the constraint would have been 4x sub 1 plus 3x sub 2 is equal to 24 pounds. So dito, yung exact equality, ibig sabihin, dapat 24 pounds ang gagamitin. Hindi labis, hindi kulang. 24 pounds. As in our maximization model, there are also non-negativity constraints in this problem to indicate that negative bags of fertilizer cannot be purchased. Okay, so wala ring non-negativity constraints dito. Okay? So x sub 1 and x sub 2 is greater than or equal to 0. The complete model formulation for this minimization problem is, so ito na yung pinaka model equation natin, ano? Minimize z is equal to 6x sub 1 plus 3x sub 2 subject to 2x sub 1 plus 4x sub 2 is greater than or equal to 16 pounds of nitrogen. 4x sub 1 plus 3x sub 2 is greater than or equal to 24 pounds of phosphate, where x sub 1 and x sub 2 is greater than or equal to 0. So, graphical solution of a minimization model. We follow the same basic steps in the graphical solution of a minimization model as in a maximization model. So, ganun pa rin, gagawin pa rin natin yung line 1 at saka line 2. Okay, para dun sa dalawang constraints. The fertilization example will be used to demonstrate the graphical solution of a minimization model. So, the first step is to graph the equations of the two model constraints as shown in figure 2.16. So, kung kukomputin nyo, yung line 1 at saka line 2, okay, para dun sa tinatawag nating material constraint, yung nitrogen at saka phosphate constraints, makukuha nyo ganyan, kung i-graph nyo siya. Okay, so ganyan ang itsura niya. Parehas din, Pero, the feasible solution area is chosen to reflect the inequalities in the constraints as shown in figure 2.17. So, ang pinagkaiba nito, okay, kung kukunin ko yung aking highlighter, hindi ba dun sa maximization, okay, nakikita nyo tong highlighter ko. Ito kasi, di ba, itong area na to, ang concern natin sa maximization Okay, nakikita nyo yan. Yung inano ko ng yellow. Okay. Yan ang concern natin pagdating sa maximization model. Pero pagdating natin sa minimization, kabaligtaran. Ang ating concern naman, itong area na to. Okay? Itong area na to. So, ganyan siya, Yung area yung pataas na yan. Okay? So, yung area yan. Okay? Kung yan ang ating concern. Okay? Hindi masyadong perfect ang aking pagkaka-shade. Okay? Pero at least you got the idea. So, yan ang concern natin. Yung naka-red na shade na yan, yan ang concern natin pagdating sa minimization. Yung naka-yellow, yan ang concern natin sa maximization. Okay, so nakuha niyo yan? Okay, let's continue. After the feasible solution area has been determined, okay, the second step in the graphical solution approach is to locate the optimal point. Okay, doon sa maximization, dahil nakita na natin yung feasible solution area, nakita na rin natin yung point A, point B, point C, di ba? Dito rin ganun din, pero iba naman yung point A, point B, point C natin dito. Figure 2.18 shows the three corner points A, B, and C and the objective function line. Okay, so i-highlight ko uli. So ngayon naman ang ating mga point A, B, C nag-iba na. Dito yung first point, okay? Second point, tapos third point. Yan. Okay? Yan yung ating concern ngayon. Okay? So, ngayon, titingnan natin, okay, pagka gagawin natin yung Z, pag nakuha na natin yung point A, point B, point C, titingnan natin ngayon sa Z, dun sa profit natin, kung alin yung may pinaka mababa na sagot. Yun ang magiging optimal solution natin sa minimization model. Okay, recall that in a maximization problem, the optimal solution is the point that can yield the highest profit. Okay? Maximization, highest profit. Sa minimization naman, the optimal solution point in a minimization problem is the point that can attain the lowest cost. Okay? So, for the sake of time, kinumpute ko na kung ano yung point A, point B, point C for your own convenience. Pero pwede nyo rin computein itong mga to, ano? So, point A, ang nakuha natin, x1 is equal to 0, x sub 2 is equal to 8. Point B is x sub 1 is equal to 4.8, x sub 2 is equal to 1.6. Point C naman is x sub 1 is equal to 8, x sub 2 is equal to 0. So, kung kukomputin natin itong mga to, isa-substitute natin dun sa profit function natin, okay, yung objective function natin, which is 6x sub 1 plus 3x sub 2 is equal to z. For point B, ang makukuha natin ay $33.60. Hindi pa natin alam ngayon kung ito ang lowest cost. Okay, for point C naman, ang nakuha natin is $48. So obviously, hindi yun ang sagot. Kasi mas mababa nga yung point B, 33.6. Pero, yun ba ang tamang sagot? 33.6. Kung kukomputin natin yung point A, ang makukuha natin ay $24. Yun ang pinakamababa. Therefore, that is the optimal solution. The lowest cost attained. So, kung i-interpret natin itong sagot natin, ang ibig sabihin nito, this means the farmer should not purchase any super grow. Okay, hindi siya bibili ng super grow, but instead, should purchase 8 bags of crop quick at a total cost of $24. Okay? So, nakuha nyo yun. Point A ang tamang sagot kasi pinakamababang gastos ang nakuha niya, $24. Hindi daw dapat siya bumili ng X sub 1 ng super grow. Kung hindi, dapat bumili siya ng 8 bags ng crop quick X sub 2 para yung cost niya, yung gastusin niya, nasa minimum lang, $24 lang. This time, kung sa maximization model, merong tinatawag na slack variables. Dito naman sa minimization model, meron tayong tinatawag na surplus variables. Okay? Greater than or equal to constraints cannot be converted to equations by adding slack variables as with constraints. So, kung hindi natin pwedeng apply dito ang slack variable. Kasi, kung sa maximization, ang concern natin yung unused resources, dito, yung natitira pang resources, okay? Yung aside dun sa minimum, yung pang idinagdag natin, yun ang ibig sabihin ng slack variables. So, recall our fertilizer model formulated as minimize z is equal to 6x1 plus 3x sub 2. Okay, so nandyan yung ating tinatawag na fertilizer model. Malinaw sa atin ito, ano? Because this problem has a greater than or equal to constraints as opposed to the lesser than or equal to constraints of the Beaver Creek Pottery Company maximization example, the constraints are converted to equations a little differently. So, titingnan nyo to medyo mas kakaiba ito kaysa dun sa slack variables. Instead of adding, okay, remember, slack variable, adding. Instead of adding a slack variable as we did with a greater than or equal to constraint, we subtract a surplus variable. So, surplus, mina-minus naman ito, nile-lessen, dinideduct. Okay? Slack variable, ina-add. Surplus variable, dinideduct. Whereas a slack variable is added and reflects unused resources, okay, yun ang slack variable, yung mga hindi nagamit. A surplus variable is subtracted and reflects the excess above a minimum resource. Okay? Maliban pa dun sa minimum resource, ilan pa yung idinagdag. Yun yung ibig sabihin ng surplus variable. Like a slack variable, a surplus variable is represented symbolically by S1 and must be non-negative. So for the nitrogen constraint, the subtraction of a surplus variable gives 2x sub 1 plus 4x sub 2 minus s sub 1 is equal to 16 para maging equal siya. The surplus variable S1 transforms the nitrogen constraint into an equation. So, kung ilalagay natin yung dun sa tinatawag nating point A, okay, dun sa ating nitrogen constraint. So, ang makukuha natin, yung ating surplus variable is 16 pounds of nitrogen. Ibig sabihin, maliban pa dun sa minimum na 16 pounds, okay, nagdagdag pa tayo ng 16 pounds of nitrogen. In this equation, S sub 1 can be interpreted as the extra amount of nitrogen above the minimum requirements of 16 pounds that would be obtained by purchasing 8 bags of crop quick fertilizer. So, yung surplus variable ay yung idinagdag na resource maliban pa dun sa minimum amount. In this case, nitrogen. So, ganun din, pagdating dun sa phosphate, in a similar manner, the constraint for phosphate is converted to an equation by subtracting a surplus variable S2. Okay? 4x sub 1 plus 3x sub 2 minus S sub 2 is equal to 24. So, as is the case with slack variables, surplus variables contribute nothing to the overall cost of a model. Okay? For example, putting additional nitrogen or phosphate on the field will not affect the farmer's cost. The only thing affecting cost is the number of bags of fertilizer purchased. So, as such, the standard form of this linear programming model is summarized as minimize z is equal to 6x sub 1 plus 3x sub 2 plus 0s sub 1 plus 0s sub 2 subject to 2x sub 1 plus 4x sub 2 minus s sub 1 is equal to 16. 4x sub 1 plus 3x sub 2 minus s sub 2 is equal to 24, where x sub 1 and x sub 2 and s sub 1 and s sub 2 is greater than or equal to 0, not a negative number. So figure 2.19 shows the graphical solutions for our example with surplus variables included at each solution point. Okay, so nandyan yung point A, point B, point C. Nakasulat dyan yung mga x sub 1, x sub 2, s sub 1, s sub 2 ng bawat tinatawag nating points. Therefore, point A is yung tinatawag nating optimal solution. So, as a summary, the two example problems in this chapter were formulated as linear programming models in order to demonstrate the modeling process. These problems were similar in that they concerned achieving some objective subject to a set of restrictions or requirements. Okay? An objective function with limited resources or constraints. So, pumapasok din dyan yung tinatawag nating economics problem. Unlimited wants with limited resources. Linear programming models exhibit certain common characteristics. Number one, an objective function to be maximized or minimized. Number two, a set of constraints. Number three, decision variables for measuring the level of activity. And then number four, linearity among all constraint relationships and the objective function. The graphical approach to the solution of linear programming problems is not a very efficient means of solving problems. For one thing, drawing accurate graphs is tedious. Moreover, the graphical approach is limited to models with only two decision variables. However, the analysis of the graphical approach provides valuable insight into linear programming problems and their solutions. So, hindi naman ito ang ultimate solution kasi. In fact, it is not a very efficient means of solving problems. Pero, yung paggamit ng graphical approach, nagbibigay ito ng malalim na pananaw pagdating sa programming problems at sa kanilang mga solution. Nagbibigay ng malalim na pananaw sa atin para magiging mas maigi yung ating decision making bilang mga managers. In the graphical approach, once the feasible solution area and the optimal solution point have been determined from the graph, simultaneous equations are solved to determine the values of n at the solution point. Okay, so that wraps up our study of chapter 2. Okay, we presented it in 3 parts: linear programming, model formulation, and graphical solution for maximization and minimization. So, if you have any question or feedback or a reaction to our study of chapter 2, please prepare these questions para pagka nagsama-sama tayo ulit sa ating Zoom consultation meeting ay mapag-usapan natin itong mga tanong na ito and hopefully mabigyan linaw, masagot natin itong mga katanungan na ito. Okay, thank you for joining me in this lesson. I hope you learned a lot. Okay, and God bless you.